Welcome inside the rotary engine assembly line at Japan's Hiroshima engine plant in the 1990s. Right now, you are watching the production of a 1.3-liter twin-rotor Wankel rotary engine. This engine was introduced in 1991. It was the world's first mass-produced sequential twin-turbo engine. Over 100,000 of these engines were produced. This number is very similar to the total number of Mazda RX-7 cars that were manufactured. As this particular engine is the Mazda 13B REW rotary engine, which was produced from 1991 to 2002. It debuted in the third-generation Mazda RX-7 and remained in production until the end of RX-7 production in Japan. One interesting fact is that Mazda hand-selected and measured many critical rotary engine components much more carefully than was typical for piston engines. Rotary engine assembly required very tight tolerances for rotor housings, apex seals, and eccentric shafts, and experienced technicians performed much of the precision assembly and inspection. This attention to detail is one reason the 13B REW became one of the most respected production rotary engines ever built. This engine wasn't built like a typical piston engine with loose tolerances. Mazda treated it like a precision instrument. Every rotating part, such as rotor housings, eccentric shaft, apex seals, and clearances, had to be perfectly matched. Even tiny deviations could hurt compression and sealing. Rotary engines depend on apex seals, so rotor housings needed extremely precise finishing. Even tiny flaws could hurt compression or cause wear, so quality control was much stricter than in typical piston engines. Mazda stopped installing the 13B REW in new production cars after 2002. However, it has continued to supply replacement engines and parts for enthusiasts through its motorsports and parts programs. As you can see right now, the manufacturing procedures and hand assembly processes used for these rotary engines in the 1990s were very similar to how they are carried out today. There are, of course, differences in tools, measurement technology, and production efficiency, but the traditional method of careful, precision-based assembly has remained largely unchanged over time. In the 1990s, Mazda sold more vehicles overall, especially during Japan's stronger domestic automotive market period. At that time, Japan's economy was larger in terms of domestic car demand, and Mazda also had a broader lineup and higher production volumes globally. Mazda officially restarted rotary engine vehicle production in June 2023, after an 11-year gap since the discontinuation of the RX-8. This rotary engine is built at Mazda's Ujina Plant No. 1 in Hiroshima City. This factory handles global rotary EV assembly. After cooling and solidifying, the casted parts are removed from the molds and undergo further machining, polishing, and quality inspection before assembly. After casting, the rotary engine parts, housing, rotor, and side plates, move into machining, where the real precision is built in and perfect sealing is set. First, the raw cast housings are clamped into CNC machines, which strip away excess material and bring every surface down to exact tolerances. This step is critical, because in a rotary engine, even the smallest deviation can compromise apex seal contact and overall compression. Apex seal grooves must be machined with extreme accuracy to ensure proper sealing and compression. All of this is built on precision aluminum castings that define the engine's lightweight yet durable architecture. Mazda uses high-precision casting and CNC machining because rotary engines demand extremely tight tolerances compared with piston engines. Even tiny dimensional errors can reduce compression or apex seal durability. Now the engine machining at this Hiroshima plant is completed, and after testing, we will move on to the next part of the production process. This is a high-speed flame spraying process used to apply durable ceramic coatings onto key rotary engine components. When these ceramic particles strike the housing surface, they flatten instantly and bond layer by layer, forming a dense, extremely wear-resistant coating. The engine assembly process is more handcrafted and inspection-intensive than many standard four-cylinder engines. Side housings are then added to enclose the working chambers. Apex seals and corner seals are installed to maintain compression and ensure smooth combustion sealing. Supporting systems include oil metering components for precise lubrication, along with intake and exhaust systems that manage airflow. Right now, you're watching a small team of Japanese factory workers assembling these exceptional engines. There are only a handful of them, and they're highly specialized for this precise, delicate work. In the MX-30 rotary setup, a generator coupling connects the engine to the electrical system, allowing it to function as a range-extending power source. Rather than a large workforce, Mazda's Hiroshima Rotary program relies on a small team of specialists and advanced automation to achieve the precision its rotary EV range extender demands. Unlike traditional hybrids, The wheels in this Mazda are always driven by an electric motor. The rotary engine only generates electricity to recharge the battery or support the electrical system. The battery pack assembly process begins with the precise installation of individual cells, followed by the integration of an advanced thermal management system to control heat under load. Dedicated cooling systems are then incorporated to maintain optimal operating temperatures. Each pack undergoes strict electrical safety validation to ensure reliability and protection. Finally, the entire assembly is sealed, locking in performance, durability, and long-term stability. The MX-30 body structure is engineered around EV battery integration, advanced side impact protection, and a balance of lightweight design with high rigidity. Mazda chose a relatively modest 17.8 kilowatt-hour battery because the rotary generator extends total range. While Mazda relies heavily on robotic welding for consistency and precision, human inspection stages are still built into the process to ensure every detail meets strict quality standards. A 125 kilowatt front electric motor provides the driving force. Energy is supplied by a 17.8 kilowatt-hour lithium-ion battery. And now, as a reward, you can watch the process of joining the powertrain with the upper part of the body. An 830 cubic centimeter single-rotor 8C rotary engine never drives the wheels directly. In the case of the Mazda MX-30 Rotary, this step is especially interesting because it involves a compact rotary range extender system rather than a conventional large engine. Instead of complex manual wiring, most connections are designed as quick-connect high-voltage couplings. When the body is lowered, key connectors automatically align and lock into place. Mazda engineered the rotary engine specifically as a compact onboard generator. Its small physical size, naturally low vibration, and ability to run smoothly at constant RPM make it an ideal solution for steady, efficient power generation. By operating purely as a generator, the rotary engine can run within a much narrower, optimized speed band, unlike in sports car applications, allowing it to stay in its most efficient range and deliver smoother, more consistent performance. Historically, rotary engines have been associated with higher hydrocarbon emissions and increased oil consumption. To address this, Mazda redesigned the combustion chambers, refined the fuel injection systems, upgraded catalytic treatment systems, and improved apex seal lubrication. This is how SkyActiv X engines are manufactured at Mazda's Ujina engine plant. Human operators then step in for the critical finishing work: sensor installation, calibration, and final torque verification. Engine blocks move into a highly automated assembly line where robots install most components. But right now, you're watching the main final assembly line in action. Mazda runs a mixed model production system, so SkyActiv X engines are built alongside other SkyActiv engine variants on the same line, allowing flexible, high-efficiency manufacturing without dedicated lines for each engine type.